In today's tutorial, we will understand what is power electronics. More importantly, we will understand power electronics with the help of a light bulb. Consider a light bulb that is powered by a DC voltage source. If the voltage of the DC voltage source is V and the resistance of the lamp load is R, then a fixed amount of current will flow in the circuit as soon as we make a closed loop. This current is given by V upon R. Because the amplitude of the voltage source and the resistance of the lamp load is fixed, the current in the loop will remain constant. This means that we do not have any means to vary the power delivery to the load. If we wish to vary the brightness of the lamp, then it is impossible in this case. Variable power delivery is possible if we manage to place a transformer between the load and the source. The transformer will change the voltage level and hence the current in the circuit will get varied. Transformers can increase as well as decrease the voltage level, so one can get the variation in the power accordingly. But the catch here is that the voltage source should be AC voltage source. The transformer will not work on DC voltage source. Moreover, once a transformer is fixed, then the voltage cannot be varied in the lifetime. So again, we are stuck with fixed power delivery and a fixed brightness of the lamp load. Here comes the role of power electronics. It enables the user to vary power delivery whenever he or she desires it. Let us understand the phenomenon with the help of a simple switch. Let us again take our previous circuit. Let us put a simple switch between the load and the source. This switch, when open, will enable the operator to cut off the current delivery to the load, and hence the power delivery can also be interrupted. If we turn the switch on and off, then our lamp will also get switched on and switched off. At this speed of transition, one can clearly differentiate between the on state and the off state of the load. Let us increase the speed of the switching. As you can see, the lamp is also following the switching speed and it is turning on and off accordingly. At this stage also, one can easily distinguish between the on state and the off state, but it is relatively difficult to perceive. If we further increase the switching speed, then the turn on and turn off of the lamp load will also speed up, and it becomes more difficult to differentiate between the off and on states of the lamp. If this switching speed is increased to the order of 1000 switch on and switch off in 1 second, then it becomes almost impossible to differentiate between the off state and the on state of the lamp, and it will be perceived as glowing the whole time but with a reduced intensity of glow. There are many advantages of using a switch instead of a transformer. The switch can be used with an AC as well as a DC voltage source, unlike the transformer, which can only be operated on the AC voltage source. The switches are light and compact, whereas transformers are bulky. The production cost and time of switches are very low as compared to the transformers. Once a transformer is installed, then the voltage level gets fixed. One cannot obtain any other voltage level and hence power level. But with switches, one can vary the glow of the load or the power delivery to a load in a wide range. The operation of switches require an understanding of a concept called duty cycle, which we will understand in upcoming tutorials of this playlist. So do not forget to subscribe, because this is not a one-time thing. We are going to understand each and every converter and topology of power electronics. So subscribe to the channel, otherwise you will miss crucial tutorials. When it comes to variable power delivery, theoretically, a switch is more efficient and cost-effective when compared to a transformer. The switches used for these applications are of a special kind. These switches are operated thousands of times every second. Also, they are not controlled by the physical closing or opening of any mechanical link. These switches are semiconductor switches. They can be operated at very high frequency, and also they can be turned on or off by providing a suitable value of voltage or current. Transistor, MOSFETs and IGBT are widely used as power electronic switches. By using these specialized electronic switches, one can control the power delivery from the source to the load. Hence, the branch of engineering that deals with the control of power flow using an electronic switch is known as power electronics.